Good morning. So today we are going to see the problems which are related with problem which is related with staircase. So already we have one video that is on staircase, that is dog-legged staircase, and today we are going to see the video that is an open Newel staircase. Actually, open Newel staircase and dog-legged staircase, the difference is very less. Actually, we cannot say a difference, but it is related with your effective span. In open well staircase, we are with three flights, whereas in dog-legged staircase, we are with two flights only. So open nail, or we can say open well, one and the same thing. Now a open nail staircase for the following data, we have floor to floor height 3900 millimeter, width of support 250 millimeter, rise we have 150 millimeter, trade we have 300 landing 600 millimeters. Number of rises, actually in first and third flight that is given 10, and in a middle flight we have 16, because you can see we have total that is 3900. You can see over here. So if you will divide this, so 3900 divided by 150, then you can see we have 15 twos and 15 sixes. 26 rises steps we require, means risers we require. And that is provided 10 and 10 first and third flight. And then remaining 6 we have in middle flight. Now if we have 10 risers, then how many number of trades? So in first and third flight, what is number of trades? So number of trades equal to number of risers minus 1. Number of risers minus 1. So number of risers we have 10 minus 1. So we have 9. So in first and third flight we have 9 trades, and here we can reduce 1. So in this we have 5 trades. So now width of each flight is 1.6 meter, floor finish 1.5, live load 3.5, and materials M20 and FE415. Now we have given this, or we can plot this diagram, because we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have trades over here. Same on this side also. Here we have 1, 2, 3, 4, 5. So now you can see what will be my effective span. For this middle flight, we have 300 into 5. So we have 1.5 meters. Now we have given this value, that is landing width of flight 1.6, or landing we have given 1.6. Generally, landing and width are provided same. So now in this case, first and third flight, we have this as 1.6 meter. And 9 threes are, so we have bottom 2.7 meter. Now you try to understand, we have for this first and third flight, center to center distance. Now we have from center this until we have this, that is first step. Now as they have given your beam is below first step, so we have beam somewhere here below first step, and therefore we have effective span till center of this beam, and this value will be 1.6 plus 2.7 and half of this, that is half of this beam. and that is given 250. You can see here width of support 250. So what will be total value then? 2.7 plus 1.6. So it comes 3, 1, 4.3, and plus we have 0.125, and then it becomes 4.425 meters. That is first and third flight. What will be about second? So we have center to center, center of this to center of this. Then we have 1.6 plus 1.6 landing on both sides plus 1.5. So it comes 4.7. And then we have half beam from left from this side and half beam from this side. So total it will be 0.25. So it comes 4.95. So for first and third flight, it will be 4.425. And for middle flight, it will be 4.95 meters. So just we will check it. For first flight, we have 4425. What we have calculated? 4425, correct? You can see over here. So we have this will be 4425. And for second, check it, 4.95. So we have for second. Third flight, we have little bit change. So it's okay. Because in this case, we have beam on both sides. So if I will go over here, so we have beam over here. Beam will be provided here. That is a 250. And therefore from center. So we have to add 0.125 over here. And then that value becomes 4500. We have to consider maximum of the three. And maximum of the three, we have value that is 4950. And then we have L effective 4950 millimeters. Then remaining steps are same. The change main you have in effective span. Then trial depth considered as simply supported. So value 20, we know this value is for simply supported. So this is for simply supported. Simply supported. And then for simply supported, we have value 20. We are assuming modification factor. Now keep in mind here, depth required is larger. Or your steel required is also more. Steel required more. Required larger than slab. Larger than slab. And it is larger, so your percentage increases, percentage reinforcement. So you can write PT increases, and therefore modification factor reduces. So you can go to figure 4, I think, and check it. Percentage increases. Then my modification factor decreases because we are in this mesh. And if my percentage increases on this side, automatically my modification factor, you can say it also decreases as percentage increases. Then we have value of D 206.25. Then we will add effective cover 20 in this. So 226.25 millimeter, we will provide 230 millimeters. And then we have effective depth to 10 millimeters. Then we have load calculation, same, no change. We have all these steps same, except effective span we have to think a little. And in load calculation, now you can see this. Load on landing, total load, dead load plus live load, self weight of slab plus floor finish. 25D 1.5. So these calculations are same as your slabs. And then we have total load, and then we have factorial load 16.13 kilonewton per meter. Now this is most important. So now this landing, this is common for first and second, or we can say and also second and third. Second and third. So you can see if I will go to the diagram, then you can see this diagram. So this landing. So this landing we have common, that is for first flight also and second. This is common for second and third. So half load will be taken by this landing one, half load by landing two, sorry, flight two, flight one, and half landing for this taken by flight two, and half will be by flight three. So likewise, you have to make half this landing, not in case of dogleg. In dogleg, we have to take this value as it is. This will be as it is, 16.13 if we will talk dogleg. Because if we will draw the diagram for dogleg, then we have diagram in this fashion. So we have this landing will be likewise. And so if I will go like this, so this landing is only for this flight and this landing is for upper flight. So we do not have common landing for the two flights and therefore value we have to consider as it is in case of dogleg staircase. Then load on landing, we have in the same fashion, we have to consider sec phi and then total self weight. We have two factors to be considered when we will have going. One, we have to multiply self weight of waist slab by sec phi 1.118, and in this we have to add also weight of steel, which is not to be considered in your landing. So this factor we have to consider. Why we are considering waist slab means if we will multiply this value, then we are going to get this value as 5.75, which we have considered for landing. And that value is increased because we have slab as inclined by 1.118. Then 6.43, 1.875, floor finish, live load and total load and factorial load, 19.97 kilonewton meter. So this change we have, or we can say this will be as it is. There is no change if we will talk about dogleg staircase and open Newel staircase. In open Newel only we have change in load on landing. We have to make it as half because landing is common for two flights. Now bending moment calculations. Now you can see first we have 9 treads, so 2.7 meter. Then we have landing that is 1.6 meter, and we have that half beam we have considered, which will be 1.85 meters. So if we will go to the third flight, then little bit change will be there. We have to consider 1.25 on other side also. That I have not taken. So now you can go likewise also. So take moment about b equal to 0. So we have RA into this distance 2.7 plus 1.85, then minus 19.97 into 2.7. So this total load will act at center, which is 19.97 into 2.7, and CG will be half of 0.5 into 2.7 plus 1.85 because it will act at center of 2.7. 2.7 के सेंटर में ये एक्ट करेगा और उसमें we have to add 1.85, and from this we have this will be second, that is 2.7 by 2 means 0.5 into 2.7 minus 8.07 into 1.85 square by 2, and from this I will get value of RA 40.96 kilonewton. Now you can apply summation Fy0. So if we will apply summation Fy0, so I will get it, I will write over here summation Fy0. Then we have VA or RA we got 40.96 minus 19.97 into 2.7 minus 8.07 into 1.85 plus RB, and that is equal to 0. And this will gives me value of RB as 27.89 kilonewtons. Maximum bending moment will occur at zero shear force. So now here let us we will consider my zero shear force is somewhere at a distance x, and I will consider only this portion. So what I will get over here? So we have this portion, we have this force 40.96, and then with this UDL, that is 19.97. This is x, 19.97. And then we have 40 into 40.96. This is force minus 19.97x. So we are applying summation Fy equal to 0 because we have shear force 0. Shear force means summation Fy on left hand or right, and which will gives me value of x, that is 2.05 meters. So I have value of x 2.05 meters. And now I will take moment about this xx. So we have moment due to reaction 40.96 into x. X is 2.05 meters minus. Now we have load 19.97. This is on 2.05. So 0.05 whole square. So we have this will be into 2.05 square by 2. And that will gives me bending moment that is equal to 42 kilonewton meter. So if we will consider another also, that will be flight 3, then you have that value that is 0.125 will increase, will not affect a lot. Now you can go flight 2. So we have seen we have beam on both sides. So 1.6 plus 0.125, 1.5 because we have 5 treads and same 1.725. Now you can see my beam or my loading, this is symmetrical. So we have this loading symmetrical with center. And therefore we are going to get maximum bending moment at a distance 1.725 plus 1.5 by 2 center. So this 1.5 by 2, and that will gives me maximum bending moment because shear force will be 0 at center. Why? Because load is symmetrical. Load is symmetrical with center. Symmetrical with center. So if load is symmetrical with center, then therefore shear force equal to 0 at center. And therefore M max at center. And we have done same reactions. We are same because total load will act at center if we will see. And then we have maximum bending moment. We can calculate reaction. We got 28.90. So we can have 28.90 kilonewton into, we have this distance 1.725 plus 0.75. And then due to 8.07, 8.07 into 1.725. This will be total load. Where it will act center of this. Where we have this center. So we have 0.5 into 1.725 plus 0.75 plus 0.75. And then we will have this maximum bending moment 43.46 kilonewton meter. Maximum we have to consider when we will go for next step, depth from bending moment consideration. We have M20, FE415. RU max we will get 2.76, D required 125.48 less than 210 mm. Okay. Same we have reinforcement formula. I will not explain this. You can calculate this and you will get required value 588.43. We have calculated AST minimum. While calculating AST minimum, we have to consider value that is capital D. And then we have value for spacing of reinforcement we have calculated. Now this is most important. Maximum diameter we have a code clause d by 8. So we have already considered it. Then spacing we will get it as 190. So we have 10 mm, 12 mm at 190 center to center. Similarly, we can go reinforcement that is in second flight, which will be same, no change. I will not explain this again. 12 mm at 180 mm center to center. Then we can have distribution reinforcement 276, and then we have that is 10 mm at 280 mm center to center. And then check for deflection, percentage reinforcement. We have to calculate. We have considered maximum force, and then we have so that maximum steel. So that maximum steel, then your that modification factor will be less, and automatically depth will be larger. And then from this we will get required 176. We have provided 210, therefore sufficient. Now you can see the reinforcement. Now already I explained in the class, so you can have this as main reinforcement, and we are not interested to take it down. Already I explained, if you will take it down, it will try to go up, and whatever concrete is below it, this concrete will crush, and your reinforcement will be open to atmosphere, which may corrode and lose its strength. And therefore we are not going to bend in this fashion that below this we have only cover. Then we can provide likewise, we can have 2.7, 1.6 till beam depth. So likewise we have to provide, so distribution reinforcement we have 10 mm 270, and main reinforcement we have, sorry, this is 12 mm. I think we have 12 mm 90. In first flight, 12 mm 90, and in second flight we have 12 mm 180. So that correction that was remained. So this will be 190. This is okay. 10 mm 270. Is it 10 mm 270? Check it once. Sorry, 10 mm 280. So 10 mm 280. And then we have, this will be value that is 12 mm at not 120. This is 10 mm at 180 mm center to center. And this will be 10 mm at 280. So 10 mm at 280. So likewise, we have to design. So open Newel, this is also simple one. So we need not require to afraid of this. So now we will stop here only. Thank you. Remaining part we will see in the next video. Thank you.